Here we have something called the power chain rule. I don't even really know what's called that. This is really just, we've kind of already covered this. We're going to go over it again, but it's pretty important that you understand it. Y equals f of u is going to be substituted into the chain rule. And so here, let's just take a look at it. Forget all this mumbo jumbo here. dy dx equals dy du times du dx. Leibniz notation for the chain rule. So basically, that works like this. So if let's say I have the derivative with respect to x of some function f of u. Well, we're taking the derivative with respect to x, but this is not plain old x, is it? It's a u. So the chain rule says take the derivative of the outer function, so it's f prime of u, and then times the derivative of the inner function, which is going to be du dx, because we're taking it with respect to x. So an example of that would be very simply if I said that let's just say f of x was equal to the sine of x squared. Well, if I wanted the derivative with respect to x of f of x, that's going to be, again, the outer function sine, so it's going to be the cosine, leaving the inner function x squared alone, times the derivative of the inner function, 2x. So it's 2x cosine of x squared. But what if we looked at this a little differently? What if we said we had f of u equals the sine of u, but u was equal to x squared? Well, the derivative with respect to x of f of u would equal f prime of u times du dx. Well, we know that the f prime of u is simply equal to the cosine of u, because it's the derivative with respect to u. And we know that du dx is equal to 2x. So f prime of u is going to be the cosine of u. Du dx is going to be 2x. And then you simply replace what u is right here, cosine of u. U is x squared, so I plug in x squared for the u times 2x, so it's 2x cosine of x squared. So there's so many ways to look at the chain rule. And hopefully, as you look at it a lot of different ways, you can understand it. Let's take a look at this example. dy dx equals y times, or y equals dy dx. We're trying to find dy dx, for y equals the sine to the fourth power of 3x, or sine of 3x to the fourth power. That's what it really means, is right here. So again, the outermost function is raising something to the fourth power. The next link in the chain inside of that is the sine function, and the most innermost function is 3x. And you can't go any further than that. So again, the derivative is the outer function is going to be something to the fourth power is going to be 4 times something to the third. And there it is. That something is sine of 3x. Then we take the derivative of the sine of 3x. And the derivative of sine is cosine, leaving the inner function 3x alone. First time we left all of that alone. Now we leave the 3x alone, the cosine of 3x. And then the final chain is the derivative of 3x is 3. 3 times 4 is 12, times, again, sine of 3x to the third power, or sine cubed of 3x, times the cosine of 3x, and you're done. Now we're going to be looking at trying to find some slopes. Find the slope of the line tangent to the curve y equals the fifth power of sine of x, or sine of x to the fifth, in parentheses, sine of x to the fifth, okay, at the point where x equals pi over 3. So we have y equals the sine of x to the fifth power. The derivative is the power rule, 5 times the sine of x to the fourth power, leaving the inner function of sine alone. Then take the derivative of sine, you get cosine. There's my chain rule. So it's 5 sine to the fourth of x times the cosine of x. At x equals pi over 3 is where we want to find our slope. Slope and the derivative are the same. So we take and we plug pi over 3 into the derivative to get the slope. So we got sine of pi over 3, then to the fourth power, times the 5, times the cosine of pi over 3. The sine of pi over 3 is radical 3 over 2. That's raised to the fourth. The cosine of pi over 3 is a half. You got to know your unit circle. So we got radical 3 to the fourth is going to be 9. Radical 3 times radical 3 is 3. And then you're doing that twice, so it's 9. 2 to the fourth is 16. You got that times 5 times a half. So you got 45 over 32 is my slope at x when x is pi over 3. Part B says you're supposed to show that the slope of every line tangent to the curve y equals 1 over 1 minus 2x quantity cubed is positive. So we look at our function. We rewrite this as 1 minus 2x to the negative 3 power, so we don't have to deal with the quotient rule or anything like that. The power rule now, it's negative 3 times the quantity to the negative 4. Remember, when you subtract 1 from negative 3, you get negative 4. Chain rule, the inner function is the derivative of that's going to be negative 2. So I'm going to get a positive 6 times 1 minus 2x to the negative 4, which is 6 over 1 minus 2x to the positive 4. And there's no way that is ever going to be a negative number, no matter what you plug in for x, because what is ever in here, no matter whether it's negative or positive, raise it to the fourth, it's going to be positive. The 6 on top is always positive. You're always going to get a positive slope. And now here's some chain rule problems that we can go through. F of x is 2x plus 3 to the fifth. And, well, I guess we're supposed to find the derivative of that, but we weren't given very much room there, were we? So we'll go up here with this one. F prime of x is going to be, outer function is to the fifth power, so it's 5 times 2x plus 3 to the fourth, and then times 2. So my final answer is 10 times 2x plus 3 to the fourth. I would suggest you pause the video right here and see if you can do these, and then play the video and see if you got them right. This one here, f prime of x, this is really sine of x squared, so it's going to be, and I suggest a lot of times you write it like that to not make a mistake, and you will get 2 sine of x, and then the inner function is sine of x, derivative of that's cosine of x, and so that's your answer. That problem normally kids get right. The one that I've found that kids miss the most is when I would give you something like sine cubed of x. And that, of course, is going to be, that's the sine of x cubed. And that's, the derivative of that is 3 times the sine squared of x. And what a lot of kids do is forget to put that squared right there. They bring the thing around front and they forget to put the squared on there. I think it's helpful to write it like this and just keep writing it like that. So it'd be 3 sine of x squared and then times the cosine of x. And then if you want to write 3 sine squared x cosine of x, that's fine. But that's probably one of the most prevalent mistakes I've seen on calc test is not, when they put this around front, they just forget to put the squared on there. Okay, so try not to be one of those people. F prime of x is going to be the outer function derivative, g prime. Leave the inner function h of x alone, then times the derivative of the inner function h prime of x. Now we got a whole bunch going on here. So here, f prime of x is going to be, the outer function is g, so it's g prime of what? H of k of x. Leave it all alone. Don't do anything to it. Now go in here and take the derivative of that, so it's going to be h prime of k of x. And then take the derivative of k of x, and you're going to get k prime of x. So you've got a 3-link chain there. Here, f prime of x is going to be, the outer function is the sine, so it's cosine of, leave what's inside alone, 2x plus 3 to the fifth. Take the derivative of the inner function. It's going to be 5 times 2x plus 3 to the fourth. Take the derivative of that inner function. It's just going to be a 2. And so you can clean it up and put the 2 around front. 2 cosine 2x plus 3 to the fifth. And then 5. So actually I should have made that a 10 to start with. If you didn't see that. So it's 10. And then you've got your 2x plus 3 to the fourth. Remember, you can't put these together here because this is the cosine of all of that. So that's by itself. All right, so next we have f of x equals the sine cubed of x by substitution. I'm not sure what they want there. I'm just going to take the derivative of f prime of x. It's going to be 3 sine squared x times cosine x. Now, I think a lot of kids have a little bit of trouble with that until I rewrite that as the sine of x quantity cubed. So then f prime of x is much simpler seen as 3 times the sine of x squared times the cosine of x. And then you could rewrite it like that. So that will do it. And we will